Now in section 13.6, we're going to deal with areas underneath the x-axis, and what's a slight problem here is if you've just watched the video on section 13.5, you will, somewhere in there I said, look, I've skated over some of the details here. And some of the details that I skated over was what happens if the curve goes below the x-axis and the y values are negative, and it affects the whole way we look at it. Now, if you really wanted to, you could go back and look at that and think about, well, what if the curve was below the x-axis, the y value was negative, the area function would get a negative value because you times it by a negative and things like that. But essentially, in some of those details, in some of that slight skating over some of the finer points, we didn't deal with areas under the x-axis, and take my word from it, what happens is, if you have a function like this area here, let's say, I don't know, this is 1, 3 and 7. I can integrate from 1 to 3 with respect to x. I can integrate that function, and that will give me that area. If I integrated between 3 and 7, I integrated that function with respect to x, then this area here would come out negative, right? Because it's below the x-axis, the area comes out negative. So if I actually want to find that area there and this area here, I need to do this integration and do this integration, do them separately, and then add the answers together. So when this area comes out, I don't know, it comes out to be minus 6, that integral comes out to be minus 6, but the area is actually 6. So areas under the axis come out negative. So practically, how does that affect our questions? Well, when we're asked questions like example 10 and example 11, find the area of the finite region bounded by the curve and the x-axis. Well, if your curve does this, then you just need to find the x-axis crossing points and integrate between the two, no problem. If your curve does this, you need to find the x-axis crossing points, integrate between the two, and your integral will come out negative, but you'll need to put a positive sign in front of it, so no problem. If your curve does this and wiggles up and down above the x-axis and below the x-axis, you're going to need to find the x-axis crossing points, and then you're going to have a sketched graph, because when you've got the graph sketched, you'll be able to say, well, I'll integrate from this value to this value, and that'll give you that one. Integrate between here and here, that'll give you this one. Integrate between here and here, that'll give you this one, okay? Now, the big bit of advice there is sketch the graph. If in doubt, sketch the graph. Then you know what shape you're looking at. It's not going to surprise you when this one comes out negative. It's not going to surprise you when this one comes out positive. And if this one, you did it and it came out negative, then you've made a mistake. If you did this one and it comes out positive, then you know you've made a mistake. Now, something that I've learned in the teaching of the first couple of years of this course, you can sketch the graph. If it's a graph that you know how to sketch, then make a sketch of it on a piece of paper. But you have calculators that will sketch graphs for you. So there's no reason at all not to just tap that in the calculator and check it. Not only do you have calculators that will sketch graphs for you, but you have calculators that will calculate these integrals for you. So although the question is going to ask you to find that integral and you're going to have to show you working out, you can check the answer on a calculator. Okay, so sketch the graph, check the answer on a calculator. When you're checking the answer on a calculator, make sure you're taking account of this thing. For this one for example, if I integrated from 1 to 7, then I'd have a positive area here and a negative area here, and those two would slightly cancel each other out. So you need to make sure you do the two integrals separately. But your calculators will help you an awful lot, okay? Now, I'm not going to add the calculator tutorial in here for two reasons. One, I have a colleague who's about to make a load of videos on calculator tutorials, so that'll save me a bit of time, and I can link my channel to those videos as well. So if you're interested in what buttons to press, then we can do it that way. And secondly, of course, everybody's got different calculators. So if I show you on one calculator, it needs to be somewhere else. So that's better in a separate video. But be aware of the fact that you can use your calculator for definite integrals. You can use your calculator to sketch graphs. So when this comes up, your calculator will do a lot of the checking for you if it won't do the work for you. And in some cases, look carefully at the phrasing of the question in the exam. Maybe you can use the calculator to do the work. Now, last word of warning. The exam board did promise that you should be able to manage the exam without a graphic calculator. So there shouldn't be a question where you can do it with a graphic calculator and you can't do it without. But there may well be a question where it's a lot easier with the calculator than it is without. And certainly we've had one instance, at least at our school, of a student, two students in the exam. One of them used a graphic calculator and the other one didn't. And the student that used the graphic calculator found the tricky part of the question and got the question right. And the student who didn't think to put it in the calculator got the question wrong. Okay, so be aware of how useful those things can be, and make sure you know how they work. If you're not sure how they work, well, sooner or later I'll link those calculus tutorial videos to this channel.